Question number 2 is from chapter 4. We have the case of a tourist drags his luggage. Okay, so we have a luggage of mass 20 kilogram with a force of F. So this is basically our external force at a constant velocity. Okay, so bear in mind at constant velocity, the object or the luggage does not accelerate. So acceleration is equal to 0 across the floor as shown in figure above. The coefficient of kinetic friction between the rollers and the luggage and the floor is 0.4. Our mu, okay, the symbol is mu. The luggage is dragged 0.8 meter along the floor. So this is the displacement. And the first question is to calculate the work done on the luggage by the normal force. To solve this question, we have the work done by the normal force. So this is the general equation for the work done. It's Fs cos theta. So for this case, work done by the normal force is Ns, normal, time displacement, cos. So the angle between the normal and the displacement is 90 degree. For this case, as we know, the angle between normal and the displacement is 90 degree and cos 90 degree is equal to 0. Then we can straight away get the answer. Work done is equal to 0 joule. We don't need to find the value of normal as we know one of the quantity is 0. Then for the second question, the work done on the luggage by the force F. Okay, for this question, we need to solve the forces acted on the luggage. So first we draw the free body diagram. Okay, if we draw the forces acted on the luggage, we have force, then we have weight, normal, and also friction. Okay, the direction of friction is always opposite to direction of motion. Okay, so how do we know there is a friction between the tire and the floor? Because we are given the coefficient of kinetic friction. Okay, so we try to put it in free body diagram. So we have external, weight, normal, and friction. Okay, then from here, we know that this is our x-axis and this is our y-axis. Okay, and we have external force that needs to be resolved. So here we have F cos theta or Fx, and here we have F sine theta. During our angle is here. Okay, so this is our Fy. Then to solve this question, so we are going to use, first we use the forces in x component, summation of x equal to ma. Then we try to solve for x component, we have this one and this one. So it's F cos theta minus mu n is equal to 0. As we know, previously we have mentioned that the acceleration is equal to 0. Then in this case, okay, we try to substitute. We still don't know our value of F. So we have angle 37 degree equal to mu is 0.4 and we don't know n. So we have two unknown quantities or unknown parameter. We need the help from y-axis. Okay, so from the information of y-axis, summation of y is equal to 0. There's no motion in y-axis. So if we refer at this free body diagram, for y-axis we have normal, F sine theta, and weight. So we have three forces acted on y-axis. So the one that is going upward is positive plus F sine theta, and the one is going downward is negative W is equal to 0. Then let us expand the equation. N is equal to weight mg minus f sine theta. Then our m is 20. 9.81 minus f is unknown, sine 37. Okay, now we substitute our n in this equation, the first equation. Then the equation becomes f cos 37 equal to 0.4 times 20 times 9.81 minus f sine 37. Now we expand the equation, we do the calculation, then we'll get f cos 37 is equal to 78.48 minus 0.24 f. So here we have f on the right side and also on the left side. Then you'll have on the left is 1.039 f is equal to 78.48. Okay, then from here we can have our f is equal to 75.53 Newton. We are nearly the end. To get or to answer the question, we want to calculate the work done is equal to F as cos theta. F is 75.53 times displacement is 0.8 cos 37. And the answer is 48.257 joule.